Hello everyone, let us see the next concept. It is whenever I have a dependent source with a super mesh. How to solve the problem whenever we have a mesh with dependent source. So we'll see that how to identify first it is a super mesh, and if we have a dependent source, how to solve that problem. Let us see this. Let us take a simple problem. I have a current source of 15 amps. Then I have a resistor in series with a dependent current source. It is a voltage dependent, so that it will be Vx by 9. It's a voltage dependent current source. Once again, it is in series with one more resistor. Let's give the values for this. This is 2 ohms. This is 1 ohms, and this is 3 ohms. I will write 3 ohms below, since there is a voltage drop across this 3 ohms. That is Vx. So based on this, it is dependent. This source is dependent on Vx value. Here 1 ohm source, and this is 2 ohms source. So here, looking into this problem, we can say that if you observe here, there is a current source common to 2 loops. Let me take the loops here. So let us this be the I1, and let us be this I2 loop. The current flowing in this loop is I2, and the third loop, the current flowing is I3. I1 is the current flowing in first loop, I2 in the second loop, I3 in the third loop. And if you observe this, this is a current source. This current source is common to loop 1 and 3. It is common to loop 1 and 3. Right? So let us solve this. How I can approach this problem? Let us see here. So initially, if you observe that in this problem, the loop 1 current is given, I1 from the figure. I1 from figure, it is given as I1 is equal to 15 amps, because the current flowing in that is 15 amps. Right? And let me write the equation for the common current source. So that is this current source. So that is this current source. Let us write a KCL equation for that. That is V of x by 9, that equal to, so V of x is in which direction? If you look at that, I3 and I1 with respect to these two, so it is in the same direction of I3, because I3 is also flowing upward. If you look at here, I3 is also flowing upward. So hence I can write the equation I3 minus, it is opposite to current I1. If you look at the loop 1, it is opposite to current I1. So this is a equation which I can write for that. I will erase this part. So now one more thing, if you observe from the figure, so it is given here as Vx. There is a voltage drop across that one. What is Vx from the figure? Let me write the equation for the Vx. Vx. So V is equal to, we know that formula as per the Ohm's law, V is equal to I into R. Right? Let us see which all the current is flowing in that resistor. So if you look at that, there is a current I3, there is a current I2. So current I3 is coming to the positive and current I2 is coming to the negative of the voltage drop. So hence I will consider the positive of the current which is entering there. That will be I3, okay, minus the current coming to the negative is I2. I3 minus I2. And what is the R value? R value is given as a 3. So this is my Vx from the figure. I will erase this part. Right? So this is a equation for Vx from the figure. So I'll substitute this Vx in this equation here. So Vx is 3 into I3 minus I2 divided by 9, that is equal to I3 minus I1. Let us simplify this equation. This will be 3 into I3 minus 3 into I2. So if I take this 9 on the right hand side, it will be multiplied as 9 into I3 minus 9 into I1. If I further simplify, taking and equating to 0 the above equation, that will be minus, so if I take this side, minus 9 will become plus 9 I1 minus 9 I3 plus 3 I3 minus 3 I2 equal to 0. If I add this I3 terminal, first I will write the I1 as same as it is. So there are I2 is 3 into I2, and for I3 9 minus 3, that will be 6. 6 I3 equal to 0. And from the figure I know what is the value of I1, which is given, it is just 15 amps. So I'll substitute for 15 amps here. It will be 9 into 15 minus 3 into I2 minus 6 into I3 equal to 0. Let us take 9 to 15 to the RHS side. That will 9 to 15 will be 135. That will be 3 into I2 plus 6 into I3. That is equal to 135. So let us take this as equation number 1. 135 is 9 into 15. So this I got from the first equation. So let us apply KVL for the rest of the loop. If you take this loop here, there is one more loop which is left out here, this one, this loop. I will apply the KVL for this loop. Just erasing this. KVL for that loop. Applying KVL for loop 2. So where I have 2 into I2 plus 3 into I2 minus 3 into I3 plus 1 into I2 minus 1 into I1 equal to 0. So I will just go back here. So this will be 2 into I2 plus 3 into I2 minus 3 into I3 plus 1 into I2 minus 1 into I1 equal to 0. So if I simplify this, so how many I1s are here? It is only one I1 minus I1 value I know that it is 15 amps. I'll substitute for this 15 amps plus I2 is here 2, here 1, that will be 3 I2 plus 3, it will total 6 here 6 minus 3 I3 equal to 0. And if I further simplify this, it will be 6 into I2 minus 3 into I3, that is equal to plus 15. Let's take this as equation number 2. If I solve this, since I1 is already known, so only unknowns are here. If you look at the equation 1 and 2, I2 is common, I3 and I3 is common. So unknowns are I2 and I3. If you solve this above to equation, solve equation 1 and 2, we get I2 equal to 11 amps and I3 is equal to 17 amps. Right? I1 is given from the figure, that is I1 is equal to 15 amps. So this is a solution for this problem, where this problem was given and it was asked to determine the unknown currents, that are I1, I2, I3, unknown currents we were supposed to find. So we got the answer here. So hope so you got this, how to solve the problem whenever you have a dependent source with a super mesh. Thank you.